Bismillahirrahmanirrahim. Dear students, today we are going to explain some important measuring instruments regarding mass. The objectives of this lecture will be the coverage of brief history of mass measuring instruments, working of instruments like beam balance, physical balance, lever balance, and electronic balance. Also, in this lecture, we will compare these balances for the most accurate balance. Now, first of all, regarding the brief history of mass measuring instruments, it comes from the ancient Greece. They used the pieces of grains as one of the earliest unit of mass measurement. Following the Greece, Egyptians also made lumps of metal or rocks that were the same weight as a certain amount of grain. This way, shopkeepers could be consistent in how much of a certain item they were selling. They would put the metal or rock on one side of the scale balance and then pour amounts of the another item on the other side of the scale balance until both sides were equal. We also use in the modern calculations by comparison method the same method used by Egyptians. Now, towards the modern mass measuring instruments, we have beam balance, physical balance, lever balance or pen balance, and electronic balance. This is basically from historical to the most modern balance we are using nowadays. A beam balance basically consisting of a lever with two equal arms and a pen suspended from each arm. Likewise, Egyptian way of mass measurement, standard mass is placed on one side of a beam balance and then pour amounts of another item on the other side of the scale balance until both sides becomes equal. This method is called comparison method, earlier used by Egyptians. Now, this is a beam balance. This beam balance consists of a horizontal beam which is supported at its center and can move freely about its support. Two scale pens of equal weights are suspended from the two ends of the beam, this end and this end, from the equal distance from the center of the beam. A pointer is attached at the center of the beam. This pointer shows the measurement by comparison. When the pans are balanced, the beam is horizontal. In this position, the pointer comes at its main position. When the pans are empty, the pointer should come to rest at this center position. It should be vertical. When we put some mass in one pan, then the pointer is moved towards the heavier pan and until the pointer will be balanced when the masses becomes equal. Now, the physical balance is a very sensitive common balance which can be measured weights in milligrams. This is a typical diagram or picture of a physical balance used in laboratories. It is placed in a protective glass case so that even dust and wind cannot affect. This is the diagram, label diagram of the balance used in laboratory. In case of lever balance or pen balance, a lever balance consists of a system of levers. When lever is lifted, just like in this case, object in one pen and standard mass or masses on the other pen, the pointer of the lever system moves. The pointer is brought to 0 by varying the standard masses. Now let's go and measure some fruits. For this we will need 2 pan balances. In one pan we will have some fruits, and in another pan we will put some suitable mass to balance this pointer to measure the mass by using this pan balance. Now we have fruits are placed in the pan balanced, and place the weight on the other side of the balance. Now when the balance is on the side where it is more, and we will put some extra mass of standard on the other side so that this pointer becomes balanced. So when this pointer becomes balanced, here we go, this is the mass of the fruits. So by this method we can easily measure the mass of the fruits or some grocery with the help of pan balance, electronic balance, the most accurate balance we are using nowadays. Electronic balance comes in various ranges, just like in milligram, gram and kilogram. Before measuring the mass of a body, it is switched on and its reading is set to 0. Next, place the object to be weighted. The reading on the balance gives the mass of the body placed over it. This is a typical picture of the electronic balance. Now let's have some look at the electronic balance. This is an electronic balance. This is a screen that will show the reading on the electronic balance. Here we have a small g that represents a unit of gram. This is oz, also unit of mass, as well as the pound. In this side we have switch off button, on button, as well as mode and cal buttons. So this is the pan on which we will place the mass to be measured by using this particular electronic balance. When we press the on button, so the screen will go on. Now at this point this is 0, and the little arrow above the 0 is indicating towards G. G means the mass is measuring in grams. If we put some particular mass in this pan, just like these blocks, it will show some reading. Here we have 50 and the indicated arrow gives towards gram, so this means that it is 50 gram. First, the comparison for most accurate balance. Here we go for the comparison beam balance versus physical and electronic balance. If we see from this table, a beam balance has the ability to measure 100 milligram of mass, while electronic balance can even measure up to 1 milligram. So this shows that electronic balance is most accurate balance than the physical balance, and the physical balance is comparatively accurate than the beam balance. So this is today's lecture of mass measuring instruments. Thank you.